Kristen Atchison here, and we're doing our fourth lecture for early capacities in infancy, and we're going to be talking about the dynamic systems theory. So there's three main principles from dynamic systems theory. The idea that it is complex, that development is complex, the idea that there's continuity in time, and this is on all levels of the organism. So this could be on the cellular level, this could be on the cognitive level. So kind of every step along the way, there's this continuity in time, and that changes on one level, changes on an individual neuron, say, can cause changes to other areas because of that continuity in time. And the idea of dynamic stability, so that there are things that are stable that kind of happen kind of across development for different individuals, but they're dynamic in how they happen. And we'll talk about each of these in more detail. So dynamic systems theory, these developmental systems, is the idea that there are multiple paths rather than a single path. So that we all end up as adults, but how we get there is different. And then there's this web of fibers rather than a single continuous path. And these interact with each other. So changes on the social emotional can cause changes on cognition and physical development, and vice versa. That one change, that these systems are a web instead of just individual lines. And that changes in one system then cause changes to the other. That we have different paths to similar outcomes. So we all ended up walking, but how did we end up there, right? We did it different ways. We had different timelines. We did things differently, that we can have the same outcome, but we can get to it from different ways. So Esther Thelen developed this dynamic systems theory, and initially it came out of motor development, which is one of the reasons that we talk about it in this chapter. So it really came out of some of the motor development and the motor skills, and over time got evolved to this really overarching theory of development as a whole that includes cognition and social psychology and emotional development and all these different pieces of the individual, but it started out from this motor perspective. So the idea behind this dynamic systems from Esther Thelen is that we have increasingly complex systems of action for each skill. So to acquire a new skill in, say, motor development, and this applies to other forms of development as well, that there's 4 factors in each new skill. And it's really this complexity of it. So one of the pieces of it is the central nervous system development. The brain, the spinal cord, they have to be able to do those things. It has to be able to relay those messages. It has to be able to communicate. We also have to have the body's movement capacity. So what can the body physically do? Do we have the muscle to do that? Do we have the physical ability of that? A third really, so far we're talking about biology, right? A third really important piece of it is a child's goal. So you might have kids that walk later, and it has nothing to do with number 1 or number 2, but it has everything to do with number 3. They just don't have that goal. That's not the thing that they're interested in. They're interested in something else. So those child's goals play a big role too. And the fourth one is the environmental supports. So that you need all 4 of these things to have a new skill. So you need the biology, you need the individuality of the child's choice, and you need to have the environmental supports for that new skill. So back to those 3 main components that we talked about in dynamic systems theory. And again, we're going to talk about it in a lot of terms of motor skills, but it really, again, is an overarching theory that we can use for more than just motor development. So the idea that this principle of complexity, this idea that development is an integrated system, and it's composed of varying elements, like we talked about in that previous slide. So we have the biology component, we have the psychology component, and we have the social cultural component. So it's part of that biopsychosocial outlook, right? That there are multiple child and environmental elements. Again, this can be happening as low as on the cellular level. This can be happening as high as on the social cultural level. We can even, think about the things that affect behavior in terms of Bronfenbrenner's model. So it's this really complex system that's composed of all these different elements. And we have what we call multi-causality, the idea that No single element has causal priority. Not one thing is causing this change. That all of these things, the biology, the psychology, and the social cultural, are all working together to cause these changes. So new motor skills, new cognitive skills, new social skills are coming out of this complex system of change. Other characteristics in the systems is this continuity in time, that we have this self-organization or this soft assembly, that the system self-organizes itself, and that this change occurs via these developmental transitions or phase transitions. And again, that change on one level, so a change on maybe we get some better, synaptic connections. We have better brain communication. Those changes on synapses can cause changes on these other things. So again, it's this and that the system self-organizes itself in that way. The third one that we'll talk about is, again, this dynamic stability, that this system is dynamic. Again, change in even this single component can cause reorganization of the whole system, the whole child. And because of this, it's not completely predictable. So you can't say that this one thing is going to cause this one thing. It's very, very complex system, and it's dynamic in these different changes. Different elements may have larger effects in different situations, at different times, in different types of situations, than they did at other times and in other types of situations. So that this system is dynamic, this system is changing, but that we all kind of end up at that same place. We all, again, this multi-causality, that we end up at that same kind of developmental skill. More on that dynamic stability, that there's this determinism. Not all behaviors or outcomes are precisely predicted, because these behaviors or these mental processes emerge as a function of this dynamic system. So examples of this are that infants are born with a stepping reflex. And we talked about this earlier in this chapter, when you put a baby's foot kind of, on a flat surface, they kind of do this stepping. This is long before they can walk. This is not a kind of cognitive, I'm going to try and walk kind of situation. It's reflexive. And at some point, the central nervous system suppresses that reflex, but then it comes back, roughly around 12 months as walking. And so this is both that part of that central nervous system with that reflex and this cognition and motor development and choice and all of these things working together to end us back up at walking. Other things that we know about this system is that the environmental supports change this too. So, and this can be even environmental stuff like gravity, okay? So this infant stepping reflex, we know infants can do this. It seems to go completely away until walking reemerges at 12 months. Well, Esther Thelen actually did research where she put babies kind of in this like safety belt harness thing with their lower half of their bodies submerged in water. And she did this after the infant stepping reflex had disappeared. And what she found is that it actually hadn't disappeared, but it was being suppressed by the environment. So those cute, chubby little baby thighs that we all love and love to look at, all those adorable rolls, are really hard to lift. And so when she put them in water, they were able to, again, re-engage in this stepping reflex. So those cute rolls, while important and adaptive, and we need those fat stores for developmental growth and change, they actually cause a reorganization of the system and suppress that stepping reflex. And we don't see that coming back until 12 months when we've had more structural changes within the infant. Another idea behind dynamic systems theory that we already talked about a little bit is this idea of nonlinear change. Change isn't gradual, predictable, or a smooth process. Again, it's this kind of web of fibers. So it goes up and it goes down and it goes up again. It can go in different directions at different times. That these small changes can create large differences in outcomes. One of the things dynamic systems theory really uses to kind of support this idea of nonlinear change are U-shaped development and N-shaped development. U-shaped development is when you can do something, you can't do it, and then you can do it again. So the example of the step reflex. So infants can do it at birth, they get those cute chubby little thighs and they can't do it anymore, and then they build up their muscles and they can do it again. So we have this U-shaped development. We can also have N-shaped development, where you can't do it, you can do it, you can't do it, and then you can do it. And both of these are, again, really support this idea of nonlinear change in dynamic systems, that these changes in one level of a different system can cause differences in this nonlinear change and create this nonlinear change in a specific ability. And again, it's about this reorganization of the system that's causing these changes. So again, this U-shaped development, the idea that we get worse or we lose that ability. Other examples outside of motor development include how we talk about words, how we use morphology. So in learning irregular verbs, right? Young infants learn them from listening, right? And so they usually start out saying blow and blue, and they use the correct irregular verbs. Then they get taught the rule, and the rule is that when something's past tense, you add ed, and they over apply that rule, and we have blow and then blowed. And then once they get back to those irregulars, they'll go back to blow and blue. So that's an example of a U-shaped development. We've already talked about that reflexive stepping, having that reflexive stepping, cute chubby thighs, losing it, and back to walking. Again, these are why this is happening, is that there's a new factor in the system that's affecting organization. In the case of the inflectional morphology, they learned a new rule and they tried to apply the rule, but it's in English in this situation, so the rule doesn't always apply. The same thing with the stepping. There was a new factor in the system that affected that organization. So we'll think about dynamic systems theory as kind of we're going throughout the course. But again, it kind of came out of this motor development. But we'll see it time and time again as ways to think about development. For your online research, your online participation this week, an article by Esther Thelen on dynamic systems theory is your other choice of an article to summarize. Thanks so much.